Assalamualaikum warahmatullahi wabarakatuh. My name is Noryushaina Adlina binti Yusmaini. So today I'm gonna present regarding my calculation on the first individual assignment. The question given is acetone is being absorbed by water in a packed tower having a cross-sectional area of 0.186 meter square at the temperature of 293 Kelvin and the pressure of 101.32 kilopascal or 1 atm. The inlet air contains 2.6 mole% of acetone and the outlet contains 0.5% acetone. The gas flow is 13.65 kilomole air per hour. The pure water inlet flow is 45.36 kilomole water per hour. Film coefficients for the given flows in the tower are K prime YA equal to 3.78 times 10 to the power of negative 2 kilomole per second meter cube, and the K prime SA is equal to 6.16 times 10 to the power of negative 2 kilomole per second meter cube, and the gradient for equilibrium line is 1.186. So from this question, we need to calculate the tower height using the K prime YA, K prime SA and the capital K prime YA. As to aid me to understand more about this question, I drew a diagram. This is actually a general gas absorption diagram, and I also extract all the information given from the question into this diagram. As for the part column diagram, it has a gas inlet flow which denote as V1 and the gas outlet flow denote as V2. The liquid inlet flow denote as L2 and the liquid outlet flow is denote as L1. As what I had learned before, for all the calculation, just consider about the component A only. So based on the question, acetone is the one that been absorbed. So here we know that acetone is a component A. Next, for the component B is the inner air that flow through the gas stream. And the last one is component C, which is the pure water. As the pure water flow in to the liquid stream, that is why the value for the XAC is 1 and the XA2 and XP2 is 0. It is because all the total mole fraction for this both stream is equal to 1. From the question, I know that all the information regarding the A component is already given, but there is only a value that missing, which is for XA1. So what I had done is I found the value for XA1 using the material balance. So actually this is the formula for the material balance of packed column. Since the inlet is equal to outlet, so the value of L2 is equal to L1 is equal to L prime, and also for the V1 equal to V2 and equal to V prime. As we already had most of the information needed from this diagram, I simply substitute it into this formula and it's turned out to be like this. And after calculate, I can get the value of XA1 is 0.0084. Sorry, 0.00648. Next, what I want to do is the operating line. So here is my operating line. This is the P1 and this is the P2. I took a value of XA1 and YA1 as the P1 and XA2 and YA2 as the P2. After finish regarding the operating line, I continue to calculate the equilibrium line using the gradient given. So the gradient given is 1.186. I substituted this gradient into the straight line equation. It turned out to be y out equal to 1.186 as in. So to find the two coordinates to create an equilibrium line, I took any value from the graph, either from the x-axis or y-axis, and I substituted into this formula, and it turned out to be P1 is equal to coordinate 0, 0, which is at the origin, and the next P2 at the coordinate of 0.025, 0.030. So my equilibrium line turned to be like this, which is this the P1 and this is the P2. After I managed to get these two lines, I continued to find the slope for the first trial. So as for the first trial, we are allowed to use this formula. This is actually not the actual formula to find the slope, but this is only for the first trial slope. So the formula is PM1 is equal to K prime XA over in bracket 1 minus XA1 over K prime YA over in bracket 1 minus YA1, and do not forget the negative sign. So as we have all the information needed, I just substituted in this equation, and finally I get the gradient or the slope is negative 1.60. So as the first slope is negative 1.60, we need to find the coordinate, which is it's gonna be used to join the operating line and equilibrium line. So what I've done is I substitute this slope value into the straight line equation, and it's turned out to be like this. So as for the P1, I took the value or the coordinate of XA1 and YA1. After substituting into the equation, finally I got the y-intercept is equal to 0.03637. This coordinate or this y-intercept is the one that be a starter point where we join the operating line and the equilibrium line. So this is the value of y-intercept which join the operating line and the equilibrium line. To find the y(I1) and xi1, also with the y star 1 and x star 1 using this first slope. So first, to find the yi1 and xi1, the point that touch the equilibrium line, I elongate it with the dotted line to the left, and I got the value for yi1, and downward, and I got the value for xi1. As for the y star 1 and x star 1, the point of slope that touch with the operating line to the left, there is a value for y star 1, and downward the value for x star 1. So, as from the graph, from the first slope, I managed to get all this value. Next is for the second slope. This is the actual formula to find the slope. As we have got the value for xi1 and yi1 from the graph, we can use this formula to find the x minus xim. So this is the formula, and I substitute all the data into this equation, and I finally got for the value of 1 minus xim is equal to 0.9902. Next, repeat the same step for the y minus yim, but this time we use the value for yi1, and I got the answer of 0.9792. So, to calculate the slope for second trial, we need this value, which is 1 minus xim and 1 minus yim. So, the equation to find the second slope of the second trial is like this. What I had done is I substitute into this equation, and finally I got the second slope is negative 1.61. As we know that the value for the first trial slope is negative 1.60, and it is nearly equal to the value of the second slope of second trial. That's why we can say that the first slope and the second slope is accurate. For the second slope, we can obtain the value of yi2 and xi2 as well as y star 2 and x star 2. So after that, I managed to get all this value from the graph. Next, before we can calculate the height, we must first to find the value of x minus xim and y minus xim. To calculate these two values, this is the equation that we needed, and the information needed is the value of xi1, xa1, xi2 and xa2. I found this equation in the appendix given. So it's all the same. I substitute the formula in the equation, and I got the value for x minus xim is 0.003627. Next is for the y minus yim. The data that we need is a ya1 minus yi1 and ya2 minus yi2. I substitute all the data in this equation, and finally I got the value of y minus yim is equal to 0.00591. The last step before we can calculate the tower height is to find the V average and L average. So the V average formula is V1 plus V2 over 2, as well as the L average L1 plus L2 over 2. So to get the V average, we must first know the value for V1 and V2. To calculate the V1 and V2, this is the equation on how to get the value. It is V1 is equal to V prime over 1 minus ya1, while for the V2, V is equal to V prime over 1 minus ya2. We know from the equation earlier that V inlet is denoted as V prime. So we take the value for V prime, which is 13.65 kilomole per hour. I standardize first the unit into kilogram mole per second, which is 1 hour is equal to 3600 seconds. I divide the 13.65 kilomole with 3600, and I got the value for the V prime is 0.00379 kilomole per second. So as I got the value for V prime, I substitute into the V1 equation and the V2 equation. For the V1, we use the value for YA1, and the V2, we use the value for YA2. And finally, I got the value for V1 is 0.00389 kilomole per second, and the V2 is 0.00381 kilomole per second. And as I got the value for V1 and V2, I finally can calculate for the V average, which is V1 plus V2 over 2, and the value for V average is 0.00385 kilogramole per second. So next, since the L is the liquid inlet for the pure water, we can take the value for the L1 is equal to L2, as well as equal to L prime and equal to L average. So what I had done is just standardize the unit into kilogram mole per second, and as same for finding the V prime value, I divide it with the second, and I finally got the value for L average is 0.0126 kilogram mole per second. And finally, we can continue it to calculate the tower height, first using the K prime Y8. So this is the general equation or the actual equation on how to calculate the height. The height is actually represented by Z. So to ease me, I rearrange back the equation and make Z as the subject. So as we already had all the value needed, I can simply substitute it into this equation, and finally I got the tower height using the K prime Y8 is equal to 1.9457 meter. How I get the meter value is I cross out or cancel out all the unit that are same, and here is the second meter cube, while for the cross-sectional area or represented by S is 0.186 meter square. So here still left a single meter unit. That is why the tower height is in unit meter. So for the question B, we need to calculate the tower height using K prime XA. So using the K prime XA, I realized that it used the L average value. So as same as previous, I make Z or height as the subject, and I rearrange back the equation. So the equation turned out to be like this after I substitute all the data, and I finally got the height using the K prime SA is equal to 1.9647 meter. And lastly, to calculate the tower height using the capital letter K prime YA. In the question, they didn't provide me with the value of capital letter K prime YA. So to first find the capital K prime YA is using this equation. I got this equation from the appendix given. So before we can obtain the value for capital K prime YA, we must first have the value of 1 minus y star m. So to find the value of 1 minus y star m, we need this equation. This equation also can get it from the appendix. So we need the value for y1 star, or denote as y star 1. It is all the same. So I use all the data and I got the value for 1 minus y star m is equal to 0.9832. And next, we can substitute all the data into this equation, and finally, I got the value for capital letter K prime Y is equal to 0.0218, or equivalent to 2.18 times 10 to the power of negative 2 kilogram mole per second meter cube. So before we can calculate the tower height, we need the value for y minus y star m. So this is actually the formula to calculate the tower height, which represent by Z2. So we know that we are missing the value of y minus y star m. That is why first I find the value of the y minus y star m. So this is the equation where I got it from the appendix 2, and I substitute all the data of y1, y1 star, y2, y2 star, and I got the value for y minus y star m is equal to 0.01028. And I do the same as question A and B. I rearrange back the general equation to find the tower height, making the Z as subject, and rearrange back the equation and substitute all the equation, all the data, cancel out the unit, and finally I got the height using the capital letter K prime YA is equal to 1.9343 meter. So apart from this, I designed a back tower column using the first equation, which is the tower height using the K prime YA, which I got the height is 1.9457 meter. So I designed this back column using the Autodesk Inventor software, and this is how I finalized my design with this height. So I think there is all from me. Sorry for the all inconvenience and my mistake along the explanation. That's all from me. Thank you.